Hey guys, I'm here. I'm just going through double checking my settings that we went over yesterday,
Yeah.
and I'm going to
Okay.
pause the recording.
Okay.
Can you?
All right. And yeah, Dania, you beat me to it. I was just going to ask you to enable the recording. So sounds good. So let's get going. So hey, everyone, and thanks for joining. Today, myself, Kevin O'Connor, and my colleague, Taby Orwa, will be delivering this session to provide an overview, and we'll deep dive in a few areas on HashiCorp Validated Designs for Terraform, or what we refer to as HVDs, right? So this is meant to give you an introduction to the documentation, essentially how it can be used, and provide a few detailed examples of the very sort of pointed recommendations that we make in these documents. Additionally, I know a lot of folks are here for the free lunch as well too. So our field marketing manager, Dania, will be sharing the code for, I think it's Uber Eats, in the chat shortly that you'll all be able to use. Additionally, we have folks available in chat, other colleagues of ours, other solutions engineers to help answer questions. And we'll also save some time at the end to answer questions as well too. And anything we don't get to, we'll put together an FAQ document that goes out likely in a few days to address anything that's outstanding. So just a quick overview of the agenda, right? We'll go over what these HVDs are, and and there's a few different flavors of them depending on the different stages of maturity within HCP Terraform, as well as some detail on how you can apply them in the planning of Terraform and the day-to-day operations of the platform. And I'll make note now, right, that we're dealing with the enterprise offerings of Terraform. So you may hear us say HCP Terraform, which is the HashiCorp Cloud Platform offering. We may say Terraform Enterprise, which is our self-hosted option, right? But in either case, they're synonymous, and the recommendations within our HVDs apply to both. So let's get started. So HVDs, what are they, right? So this is our take on prescriptive best practice guidance documents that really outline how to operate HashiCorp software at scale. We're looking to really help our customers reduce risk and really establish a foundation for that scale, right? Moving into not just the initial setup and config, but moving into those sort of day two operations. And they're all backed by, a number of different teams here at HashiCorp. It's, everyone across all departments pitched in on these things, from engineering, product management, solutions architects, and solutions engineers, support and implementation services, you name it, they've had a hand in these documents. So setting the stage, right, what can you expect out of the HVDs, right? Our goal in putting these together was to really help our customers reduce their onboarding times by eliminating a lot of the confusion and cognitive load that goes into architectural and process related topics, right? We're really looking to provide clear guidance on our point of view, not just documentation that, tells you how you could do everything, but really what the actual recommendation would be for specific use cases, right? And we structured them really in a way to ensure they're being utilized, like I said before, not only as part of onboarding, but into sort of day 2, day 3, day 77, right, of the life cycle of our products. We really want you to understand how to build the right workflows from the beginning so that you can kind of offer these to your internal customers and internal development teams within your organization. And finally, the last point there, accelerated maturity, should be fairly straightforward, but the idea is the more quickly that you're able to get onboarded and tackle those initial use cases, the more you can, take on further use cases with Terraform and get additional value out of the tool that you're paying for. So for our HVDs, like I mentioned, we have a number of them that are out today, right? On the Terraform side, we have our solution design guide, which is really geared towards the initial sort of implementation, initial installation, architecture, if you're self-hosting with Terraform Enterprise, things along those lines. And then we have our operating guides. Currently, they're out today for what we call our adoption and standardization stages of our maturity model, which I'll touch on more in a little bit, just to provide some detail on what that's all about. And then we have a couple of integration guides that are out as well too. So we have one with another one of our products, HCP Packer, so kind of best practices on how to use Terraform and Packer together. And we have one out for a partner solution as well too, with Prisma Cloud by Palo Alto that we'll touch on as well.
Yes. So let's get on with it and talk about the Terraform Solution Design Guide. So As Kevin mentioned, our objective in providing a solution design guide is to offer that prescriptive guidance. It is intended for platform engineers, infrastructure architects, DevOps administrators, and cloud operators who want to design, deploy, and administer a highly scalable, resilient infrastructure as code platform within Terraform. Now, this guide contains a couple of sections. We have an architecture section where we provide an overview of the logical architecture, its requirements, components, and deployment modes. Now, keep in mind that this initial version focuses only on AWS, private cloud, and Docker deployments, insofar as TFE, which is Terraform Enterprise, is concerned. There is also a people section, which details the description of skills and access required to accomplish deployment. There is an AWS automated installation section that uses HashiCorp Validated Terraform modules. A section with manual installation steps, either on a VM or a bare metal private cloud environment. Then there is a security hardening section with guidance and recommendations for VM images to be used in the installation. And lastly, a section on the configuration of artifacts with the data collected from your environment and their use in the installation. Specifically here, when I talk about this installation process, I am referring to TFE, Terraform Enterprise, our self-hosted solution. So what do you get out of all of this? Well, we expect to save you significant time and efforts during onboarding. We expect that this will provide you with a secure architecture backed by HashiCorp. And finally, it will make it easier for us to support you because we'll know exactly how you're deployed if you've used the HVD.
Okay, so next up, and probably where we'll spend the majority of our time today are in these operating guides, right? So let's say we're done with the initial install and config, right? Now it's all about how we go about operating Terraform on an ongoing basis. And the first guide that we have is the operating guide for adoption, right? So I mentioned the maturity model earlier. So what does that mean, right? So let's take a look. So this is our maturity model for Terraform, right? We have these for all of our products, and I could probably spend an hour just on this slide, right? But just to kind of give you a quick overview, the maturity model really kind of provides a blueprint for how Terraform delivers infrastructure as code through what we call the cloud operating model, right? So basically, in each stage, adopting, standardizing, and scaling, we focus on three main areas that define our rows to the left, right? So the first is about, creating that best-in-class provisioning workflow. The second is for enabling or establishing Terraform as the system of record across all of your IT systems and workflows. And then the third is using that system to support the end-to-end lifecycle management of your managed resources, right? Now, this doesn't have to be a strict progression, right? If you're an HCP Terraform customer today, you may have use cases in some areas and not others, right? But this just speaks to sort of generally how our customers adopt Terraform. So I'm going to start with stage one, right? And I'll kind of give an overview on the adoption phase here in a second. And then we'll go through our HVD on adoption. And then we'll do the same with stage two. We'll give an overview on, what standardization is all about. And then we'll dive into our HVD on standardization. And then we'll kind of follow it all up with the integration guides I mentioned earlier. So starting with the adoption phase, right, it all really begins by composing infrastructure as code, right? Something many of us are all familiar with, but then dives into really enabling collaboration using a version control system like Git and providing a means for how infrastructure definitions can be sort of accessed, versioned, and reviewed by whole teams, right? Really getting into, how do you manage role-based access controls for teams to orchestrate secure, complex deployments that also scale, right? And then, finally, it touches on ensuring that we have a consistent, secure runtime environment through things like secure variable storage and dynamic just-in-time credentialing for cloud deployments.
As you saw on the maturity model slide, we have identified some common stages of maturity that allow us to categorize our customers into either that adopt phase, standardize, or scaling phase. Now, each of these sections, or rather phases of maturity, is covered in a separate HVD document, right? So the adopt operating guide does include the following sections: an overview of the document, a section on people and processes, detailing the recommendations on how to organize teams for optimum effectiveness, a section on prescriptive configuration for your very first use case, a section on discussing IAC concepts and best practices, another section on Terraform workflows and discussions on the three main pipeline workflows, that is the VCS, the CLI, and the API-driven workflows, along with the pros and cons. And finally, a section on observability that details how to leverage audit logs in order to answer questions such as who made what changes. So let's talk about people and processes. As some of you may be aware, an effective use of the Terraform tool requires a thoughtful allocation of staff resources and processes in order to achieve any kind of notable return. Now, we know that when we implement quick changes to people and processes, it can be quite difficult. And so we intend to be very practical because we understand that modifying an organizational structure is gradual and adjustments will likely be needed to fit specific requirements. So what you see on the screen attempts to illustrate the functions of different teams and how they relate to each other. Now, the platform team serves as a central hub within the organization. The security team collaborates with the platform team to establish governance policies and deployment of monitoring tools. Now, if you're in a shared service module or in a shared service model, what we term as producers configure the system to meet consumer needs. These consumers utilize those shared services provided by the platform team. And essentially what we're aiming to achieve is a golden IAC workflow. And this is a standardized, repeatable process for completing a specific task for achieving a specific outcome. Now, this document aims to provide golden workflows with two aspects in mind. Again, producers, consumers. So producer workflows that encompass module development and policy as code development with either the Sentinel or the OPA framework. Consumer workflows with landing zones to provision cloud accounts or credentials and core Terraform configuration elements from reusable modules, as well as developer workflows to facilitate the creation of IAC artifacts relevant to supporting your application component.
Okay, so now let's talk about the two main consumption models of Terraform Enterprise that we see, right? And this really provides a great discussion point to help, your platform teams determine what model they can start with, sort of depending on the level and skill of resources that they have, right? And when we look at this, when we see the sort of low to high level of technical knowledge needed and low to high, needs for customization, we're really looking at that from the view of the consumer teams or application teams internally, right? So typically you'll have your platform team who owns Terraform, maybe they're defining modules and policy and really enabling self-service, that sort of a thing. And then there's a number of app teams who are consumers of that platform, right? So with the service catalog approach, typically the platform team has much tighter control over what the end users do, right? Modules are sort of strictly defined and comprise most of what the organization allows for deployments, right? And that really offers the organization more standardization and a more uniform developer experience. In terms of what's deployed, right? Because things are only being deployed that have been sort of previously defined by the platform team and approved ahead of time. The con on that sort of side is that it often results in more resource-intensive efforts from the platform team because they're needing to define everything that's ever going to be deployed, right? Then we have more of the infrastructure franchise model, right? Where the platform team more or less provides policy guardrails around deployment, but gives application teams more flexibility in what's able to be deployed. As you can imagine there's more of an effort focused on policy and maybe less in module development. It may not be zero, but probably far less than the service catalog model, right? So you may wind up with sort of less standardization in terms of deployment, but you still have peace of mind, that it's secure because of the heavy emphasis on policy.
Yeah, Kevin, that brings up a very interesting point. Now, I've spoken with a bunch of customers who are unclear on how best to manage their RBAC controls. And to most effectively secure their environments while also allowing for flexibility of self-service. Is there something that the guide can provide?
Yeah, definitely. And that actually segues perfectly into the next section on what we call Terraform object planning, right? We essentially want to make sure our customers have a good understanding of the important kind of Terraform objects, as we call them, and how they should be organized to allow you to scale, right? This is something we get asked about all the time. Like, how do we structure Terraform? How should the hierarchy be laid out? What should be contained within our organization and projects and workspaces, right? We want it to be secure, but we also want it to scale. So how do we go about doing that, right? So let's take a look at, a screenshot from the HVD to sort of walk us through this, right? So if we take a look here, there's really two main components, right? There's the structure of HCP Terraform, and then there's the way that we delegate access to that structure and the resources within, right? So for each layer of the structure, we have the organization, projects, workspaces, and resources, right? We essentially want to be mindful of what's in those layers, because we're going to have multiple projects and workspaces and resources. And then we want to be mindful of the teams and users within that have access to those layers and all the components within, right? When you break it down, that's really what RBAC is all about, right? So mapping this out in Terraform, starting at the organizational layer, right? Ideally, you'll want to create a single organization for your company for total centralization of control and governance, right? Some cases that's not it's not doable, and we understand that, but kind of ideally that is what you would like. And before even getting into the details of the Terraform RBAC side of things, that organization is going to be tied to your corporate SSO, right? So you can streamline user onboarding and offboarding processes and really enforce strong authentication from the start. Then once you have SSO taken care of, you're going to have an admins or an owners team within HCP Terraform, right? Which is typically a small group of trusted users that have permissions to manage those high-level settings and policies, right? So they're going to be able to do things like manage organizational level policy that should apply to everyone in all deployments. They may authorize connections to version control providers as part of deployments. They might manage SSH keys that are needed for deployments. They may have the ability to override failed policies, in certain circumstances. Most likely, they'll be able to publish and delete modules from the registry that are available to the wider base. And then they can actually go ahead and create and delegate some of those responsibilities to other teams, right? Moving on from like organizationally and the owner's team, right, and getting into projects, which is the next layer down in the structure, right? Projects are actually just made up of workspaces, which in reality are tied to state files. So if you're a Terraform Community Edition user today, each state file is going to map to a workspace, right? And so projects are essentially composed of multiple state files, or in HCP Terraform speak, we call them workspaces, right? And so with projects, they are really the main organizational tool to kind of delegate the configuration and management responsibilities in this sort of a multi-tenant setup that we're looking for, right? Most oftenly, we see that they are actually allocated to an application team, and we'll recommend 2 standard project level teams to achieve a kind of secure and scalable delegation of permissions within a project or an application, right? First, we'll have an admins team at the project level, and then we'll have another team for kind of maintenance or contributors at the project level as well too. And so the admins team within the project can manage the project itself. They can manage users. They should be defining project level policy. Like, let's say there's a specific, an application specific budget that should be adhered to. Maybe they want to define that and enforce it. Again, maybe they can have the ability to override policy failures or enable other modules for use by the team. And then we'll have the contributor team within the project that, say, just has the ability to perform, their deployments as necessary within the project, right? So at the end of the day, the project really lets you maintain kind of the required permissions for specific applications while also enforcing that principle of least privilege, right? We all strive to hit. And then finally, workspaces, as I mentioned before, are really tied to individual state files. So the main consideration there is around isolation. Each workspace should be an independently managed unit of infrastructure, right? Kind of isolated from other workspaces to prevent unintended changes. You essentially want workspaces to be able to be updated on their own without sort of negatively impacting other areas of your environment. With the workspaces, oftentimes the recommendation comes down to application tiers within a single app. So maybe, within our app at the project level, our workspaces are, web app and DB, right? Or actually more commonly, we recommend workspaces for environments and separating environments within a project. So that same kind of example where we have the app at the project level, and then we'll have like dev, test stage, and prod workspaces comprising that application, right? So all in all, by kind of following that approach, you kind of achieve that balance between secure, centralized control and flexible self-service access for different teams and users. Continuing on with the relationship between people and process, the HVD goes on to define some important workflows for the platform team. One of those being the recommendation for onboarding of teams into Terraform Enterprise, right? So typically there's a platform team who's responsible for managing and delegating access to additional teams. And this platform team can take advantage of a concept that we call control workspaces, right? Or, what you can think of in kind of industry speak as sort of a landing zone workspace for Terraform. So you have this landing zone or management workspace that's deployed and managed by the platform team, and they use that during the onboarding of an internal customer, right? So they'll have some automation set up, which is used to deploy, the operational environment, say for this business unit, right? That's needed by that internal customer, right? Or additional business units, whoever it may be, that has the resources within to support their development responsibilities.
Yeah, Kevin, could you walk us through what this looks like in practice? What does it look like to implement something like this?
Sure. Yeah. I love this. So the approach typically involves leveraging the Terraform provider, right? So essentially using Terraform to manage your Terraform workspaces. So you have standardization on how things are deployed, right? So you're essentially taking an infrastructure as code approach to managing your HCP Terraform implementation, right? So typically this platform team or owner's team will manage a process using a Terraform module and likely a VCS template that they manage, which are called on when new application teams want to onboard. And that module will create the management workspace for the application team. It also might create a VCS repository for that application team to store their code, and then any other variables or cloud resources as necessary for them to complete their deployments, right? So in practice, it looks something like, a pull request being opened by the app team or another business unit against the owner's repo, which the owners then review and approve, right, to kind of automate the deployment of the app team's sort of projects, resources, workspaces within Terraform, right? Because the owners will have the code for their landing zone module in their top level repo and workspace. And this is actually where they're going to, collect and manage all of the onboarded teams, right? Giving them sort of a single view into all the teams that are onboarded into Terraform. And now that owner's team, when they commit that pull request, right, they're essentially then running their top level workspace, which then uses that landing zone module to deploy the workspace that's needed for the application team, right? So that's typically how it works. And it can break out a couple different ways depending on the self-service model that you've employed, right? Thinking back to the two models I spoke about earlier, where in, a franchise model, maybe the app team actually has, write access to that VCS repo that they have. They can edit, config, and deploy additional resources as needed. And the platform team feels comfortable because they've set up the policy beforehand. Or in more of the service catalog model, the app team may need to hook into subsequent sort of request processes for, pre-canned infrastructure modules that have been defined by the platform team, right? So I know that's a lot, right? And if you're not familiar with the Terraform provider or this sort of a GitOps flow, it might be, a lot to take in, but it's all about having the code available in the platform team sort of overarching management workspace to then automatically deploy child projects and workspaces for application teams, all by using Terraform. And I'd really urge you to dive into more detail in the HVD if you're interested in learning more. Then real quick, we talk about some additional integrations and walk you through step by step on how to connect version control repositories and set up your SSO.
So the purpose of this section of the document is to provide you with the understanding of the fundamental concepts and terminology you will need to know before you dive into the composition, recommendations, and guidance of infrastructure as code with Terraform. Okay, on to Terraform workflows, streamlining that process. To simplify this, you can take advantage of the VCS integration feature in the VCS-driven workflow, which uses webhooks to directly integrate with VCS repositories. It allows you to implement again that GitOps workflow without needing custom pipelines.
Yeah, so Taby, I speak with a lot of my customers who have, net new workflows, right, which they can leverage the VCS-driven workflow for. But, they also a lot of times have pre-existing pipelines that they need to integrate with Terraform. Are you able to provide any recommendations for how they can align there?
Absolutely. So while we recommend the VCS workflow for its efficiency and the fact that it's very straightforward, should you prefer to utilize CI/CD pipelines, we provide pipeline templates to facilitate this. I do want to say, though, that we currently provide templates for GitHub and GitLab, though you can use the underlying workflow tooling to build an integration for any other CI/CD pipeline should you choose to do so. So let's get into it, right? So the API-driven workflow, it offers you complete control over the IAC process, right? Making it more compatible with your custom CI/CD pipelines while utilizing the Terraform API, which is available on our developer website, and there is a Swagger doc in there. Now, this workflow entails a couple of steps. You define variables for the organization, your workspace, and projects. You prepare the configuration file for uploads. You solicit the workspace ID. You create a configuration version. And finally, you upload that configuration version. Now, the API-driven workflow can be enhanced by leveraging pipeline templates. Again, we provide and maintain templates for GitHub Actions and GitLab. So let's take an example. A typical GitHub Action workflow includes generating a plan for each commit to a pull request branch, which can be reviewed in Terraform. So once you update that VCS branch, the configuration is automatically updated. Now, on configuring your GitHub Action, you can create and merge a pull request to test your workflows. And Terraform has built-in support for webhooks that facilitate this generic workflow. Now, keep in mind again, by leveraging our Terraform GitHub Actions, you can still design a custom workflow with additional steps before or after the standard TF operations. Now, a quick note here is that there is also a CLI-driven workflow that can easily transition you from using the Terraform Community Edition CLI commands to Terraform agents that trigger the build process. Okay, on to observability. What is observability? It's about being able to look at the live outputs of the system running in production and answer questions about what's going on. Now, this section of the document focuses on setting up a system so that you have access to real-time data about what the system is doing. We expect that you will capture this data and analyze it to make decisions with goals like detecting failures, performance degradation, capacity planning, or intruder detection. Now let's move on swiftly to standardizing. Now, standardizing is a transition point. It focuses on the shift to a more structured and efficient approach to IAC. In this phase, you are increasing your efficiency, you're enhancing your security and compliance protocols, and you're setting yourself up for scalable growth and better collaboration. Right.
Yeah, Sorry,
Yes.
Taby, quick question. Are you able to provide an example of kind of a process by, how you'd go about standardizing your infrastructure?
Absolutely. So we can have a checklist of sorts where you begin by, one, assessing and evaluating your current infrastructure practices. Where are the inconsistencies or manual steps that need improvement? Step 2, you define and set clear goals for your standardized approach. What are your unique needs and the industry's best practices? Step 3, you go forward with the implementation. Did you choose the right tools to help? Step 4, you train your teams and you make sure they understand the new workflows and how to use the tooling. Step 5, iteration begins. Are you regularly reviewing your processes? Are you able to adapt as your needs and technology evolve? Now, I want to highlight that if you look at the left-hand side there, that section that is specific to run task, that is an optional section that is usually dictated by specific integration requirements. So on building a checklist for the standardizing phase, we want to make sure that 1, you have a golden image build and hardening pipeline that uses something like HCP Packer. 2, we want to ensure that you have health assessments enabled across all your workspaces. 3, we want you to make use of the private registry. And 4, we want you to utilize Sentinel policy as code. Again, the run task portion is optional. What is a run task for some of you who might not know? It's a custom third-party integration that you can insert into your Terraform workflow, and you can use it to extend compliance, security, cost, and any visibility capabilities. Now, I talked about health assessments, right? So Terraform can perform automatic health assessments where you continuously check for changes in actual infrastructure against the expected state. Now, we cover drift detection and continuous validation. What is drift detection? So think of your Terraform configuration as a blueprint of your infrastructure. Drift detection automatically spots if the real thing doesn't match the plan anymore, and it will help you remediate the problem. What is continuous validation? Well, Terraform not only builds your infrastructure, but enforces your standard over time. Continuous validation checks that these standards are being met by regularly verifying that your configuration's custom assertions continue to pass. Now, how do we do this? We evaluate your preconditions and postconditions and check blocks in your Terraform configuration files. And on to the private registry. So, the private registry allows you to host and share your modules and providers privately. It can be an alternative to the public Terraform registry. It can also serve as a gateway to whitelisted Terraform modules and providers sourced from the public registry. You can access it via the web UI or the API, and it has 3 main functions: sharing, discovery, and consumption of modules and providers. On to the next one. Kevin?
Yeah, did it not?
Not for me. Oh, it did. Apologies.
Okay,
So
all good.
let's spend some time on module testing and version lifecycle, right? So we introduced the Terraform test command and the official test framework for Terraform in version 1.6.0. Since then, we've added mocking capabilities in version 1.7.0. Now, our recommended module publishing workflow includes testing steps, as highlighted in this diagram. So, and this diagram is in the HBD. So, for example, if you advertise to your practitioners that a module will deploy a virtual machine instance in one of the authorized regions, then you will want to, 1, expose the variables to take the target region as an input. 2, validate that the specified region is a valid one and return a useful error if it's not. 3, have a test suite that validates that given a valid region as the input, The module can deploy a VM, and if not, deployment will not occur. Very basic so far. Now, these advertised features of the module are the contracts between the module author, that is the producer, and the Terraform practitioner, the consumer. As the module author, you want to ensure that as you enhance the module or you fix bugs, you don't break that contract. You have the capability to implement unit and integration tests using that Terraform test framework. Now, a quick plug here is I just want to highlight that we've rolled out test integrated module publishing. It's available for branch-based module publishing, such that once enabled on a module, the tests will execute automatically based on version control events like a pull request and merge request. They can be initiated again via the command line or the API.
All right, jumping into Sentinel, right? As I'm sure some of you probably know, Sentinel focuses on leveraging policy as code to ensure that compliance and governance in your infrastructure is adhered to, right? Essentially allowing you to sort of define, enforce, and automate policies for provisioning to hit those sort of security and regulatory compliance standards that you have. As well as maybe some internal best practices, right? By sort of integrating those policy checks directly into your Terraform plan and apply workflow. So we go over some of the basics of Sentinel, but some of the more prescriptive recommendations from the HVD that I like to call out include the first is on an explanation of the policy enforcement workflow, more from a process standpoint side. So, basically, how can your organization define policy, begin enforcing it, and then codify it, using Sentinel, right, to ensure that it's sort of a safe rollout to all of your users. And then there are some best practices related actually to authoring and maintaining policy in your repositories, right? Ensuring that you follow best practices from a Git and, software delivery lifecycle management standpoint, right? The idea there being to ensure that, your policy, like your actual codified policy, or I should say, also follows safeguards, right? For ensuring that it too, cannot be altered and is only applied where it should be. Run tasks, as Taby mentioned earlier, are kind of an optional feature within the platform that allow you to directly integrate with third-party tools and services at at different stages within the HCP Terraform run lifecycle, right? So as she mentioned, you can use run tasks to validate Terraform config. You can analyze execution plans before applying them. You can scan for security vulnerabilities or compliance requirements, do some more detailed cost analysis, or perform kind of custom actions, right? So the HVD goes over how to implement them and which ones are available from our partner solutions like Sneak and Infracost and Wiz, right? But one of the better callouts from the HVD is actually around building custom integrations using run tasks, like how to structure your API calls, what the flow of events should look like, and how to actually test them, right? So that could be like if you wanted to integrate an internally built tool, say you have an internal, inventory or change tracking process in use, you could have a custom run task that could be used for notification of a run event, and then use the details from that run to record the activity in your internal CMDB, right? All in all, there's some nice guidance in there to help in building custom run tasks if that's of interest. Now, the integration guides, we're going to touch on them, right? The first of which is with HCP Packer, another one of our products that's available in the HashiCorp Cloud Platform. And this is really geared specifically towards the platform team that's responsible for managing golden images. The HVD is designed, and I should say, I see there are some questions. Please direct them in the chat if you don't mind, and we've got folks there who can help you out. But as far as the HVD for Packer is designed to give you best practice guidance based on our experience in partnering with a number of organizations who've implemented Terraform with Packer, right? So it starts with the people and process, as well as responsibilities required to operate a program for managing golden image workflows. Again, that's something we get asked about all the time. Like, okay, who do we need to manage this practice? What sorts of skills, what sorts of resources do we need to develop a program that will be successful for managing golden images, right? And then similar to what we've spoken about already, it goes over permissioning around sort of the various objects and hierarchy within HCP Packer, as well as a number of examples for, a golden image workflow, like for creating and maintaining base operating system images, doing the same for application images that are built on top of those base OS images. And then there's some nice guidance for security remediation workflows for when vulnerabilities are found in images, how do you go about revoking them, notifying your teams, things along those lines.
Okay, let's talk about the integration guide for Prisma Cloud by Palo Alto and Terraform. So the Prisma Cloud Runtime integration embeds Prisma library of security policies in every workflow run. It will scan and enforce them during the Terraform pre or post plan phase and report those results back to both Terraform and Prisma Cloud. Now, run tasks are driven by event hooks and are pre-configured for bidirectional communication. So if you're utilizing the self-hosted Terraform solution, Terraform Enterprise, you need to make sure that traffic from Prisma Cloud can ingress your internal network. Now, as you see on the screen, a sample workflow may look like this. You have a developer who commits Terraform code to a repo and creates a pull request to a main branch. The VCS platform triggers a webhook notification to the connected Terraform workspace. Now, at either the pre or post plan stage, depending on your configuration, Terraform will send the speculative plan information to Prisma Cloud for analysis and policy enforcement. Then Prisma Cloud will respond to Terraform and allow or deny the run. If the run is allowed, the plan is applied and the resources are deployed. Then Prisma Cloud continuously monitors the resource configuration. But keep in mind as well that Terraform itself has built-in drift detection and continuous validation features that can be used in conjunction with what Prisma Cloud has to offer. And that really brings us to the closing of what we had to share for the HVDs, right? And what do we hope that these documents and operating guides provide you, right? We hope that they give you enhanced collaboration and governance practices within your organization's IAC workflows. We hope that they give you scalability and efficiency with Terraform infrastructure provisioning, as well as an improved security and compliance posture. Now, we'll have a few minutes at the end of this to ask some questions, or at least address some of them, to address some of them. But before we go into that, I just want to move on to the next slide to talk about what we have coming up. So we'd like you to stay tuned for the next webinar in our Lunch and Learn series, which is a conversation on the Vault HVD, which we have scheduled for July the 31st at noon Eastern. So that's going to be next week. Thank you.
Yeah, and thanks for everyone for joining us today. I'd urge you to dive into the HVDs in more detail. We'll be providing a link to them if we haven't already, right? They're all available online, and to discuss further with your account teams on how you can use them or to better enable HashiCorp products internally. Last thing as well too, if you register for the Vault HVD session next week, and it tells you that you're waitlisted, just reach out to the account team and we'll make sure that that we get you in there. So no worries on that front. But yeah, I don't know, team, if there are any further questions that that popped up in the chat that we can address now. We have some time.
Yeah, I was just going to say, Pedro, you had a question about the module testing feature only being on branch-based modules, and he was wondering if it was going to be available for tag-based modules. Pedro, I had asked our product team about this question. Would you mind sending me your email via the chat so I can follow up after this call, if you're able to?
And to add on to that, we're going to try and populate an FAQ document as well that we will be shelling out after the call. So if you have your questions, if you put them in the chat, we will address them as well if we don't verbally do so now. Okay.
Yeah, I don't see anything else in chat. So yeah, once again, I mean, I appreciate everyone's time. If you have any further questions, please reach out to us or your account team, and we'd be glad to help you out with whatever it might be. Other than that, thanks again for joining today, and hopefully we'll see you next week.
Thank you.
All righty. Take care.
Bye.